Hello everyone, my name is Rishabh Gupta and this is the module 9 of our data science assignment. In this model, we will study about regression modeling. So regression basically involves two variables. One is dependent and the other is independent variable. We make predictions about the dependent variables on the factors that are affected by independent variables such as how much a student scores in exam. It is our predicted value what we want to predict, and the other variables such as how much the student studies, how much sleep it gets, how much he has scored in previous examination. These are the independent variable which may or may not affect the predicted value. The program 9.1, which is about regression, once we run this program we will get a chart about our predicted values and the independent values. So moving on, for regression models, we use evaluation techniques such as cross validation. Here is data divided into multiple subsets for training and testing the residual analysis. So, in regression, our first question was demonstrate estimation model evaluation using Python. So, we have already did that. Now, the second question about regression modeling is demonstrate stepwise regression using R/Python. We have Python here. So our program 9.2 py. This program uses the pandas library, stats model and numpy. Once we run the program, we get the output, our dependent and independent variable with their p values. So this is about regression. In the next modules, we will study dimension reduction, logistic regression modeling and association rules. Thank you. Hello everyone, this is module 10th of our data science assignment. This module is about dimension reduction. So as the definition states, the dimension reduction is a technique used to reduce the number of features in the dataset. Our main goal is to minimize the computational power and the complexity of our dataset data model. There are various techniques such as principal component analysis, PCA, which we'll see further. We have programs for this in Python language. So let's move into it. First, we will need to identify multicollinearity using Python. Multicollinearity is a statistical phenomenon when we have two predictor variables after the process of regression, and those predictor variables are highly correlated. So if there are multiple predictor variables, it will be hard for us to determine which one to use for our analysis. This correlation can cause issues in the estimation of regression coefficient, leading to less reliable and interpretable result. Interpretable result. So we need one predictor variable, and when we get multiple, this is the multicollinearity phenomenon. We have the program related to this where we have data variable x, and variable z. So we are using the pandas library here. Once we run the program, we get the different variable and their VIF values. The next is demonstrate how you will apply principal component analysis using Python. PCA, principal component analysis, its primary purpose is to transform the correlated variables into a new set of uncorrelated variables called principal components. We also have a program related to this, which is 10.2 PCA, principal component analysis. Yeah, these are our different principal component analysis points. These principal components capture the maximum variance present in the original data. So these two questions present in module 11th of our data science assignment. We have logical regression modeling. Logical regression modeling is a statistical technique used for predicting binary outcomes. For using this with Python, we need to import such libraries such as scikit-learn and stats model. So our first question related to logical regression modeling is how to perform logistic regression using Python. So a little overview of logistic regression is a statistical model method used for modeling the probability of a binary outcome, which means the dependent variable can take only two possible values. It's either going to be 0, it's either going to be 1. It's widely used in various fields including biology, medicine, and all these fields stated here. We will jump right into the program. Our program about logistic regression is this. As we know, we will need to import our stats model, sklearn. Once we run the program, we get precision, recall, F1 score, and support all this different parameters upon how our data is going to perform. Our next topic is how to perform Poisson regression using Python. Poisson regression is a type of regression analysis used to count it up. Basically, it works on Poisson data where the outcome is a number, like such as some events happening, how many planes come and go from a airport, how many calls do a user get in a year. This sort of data is called Poisson data, and Poisson regression is used to work on this data, such as represent the number of event or occurrences within a fixed unit or time or space. It is particularly suitable when the data follow a Poisson distribution, where the probability of distribution for discrete variables representing the number of events occur in a fixed interval of time, such as the number of calls a user get in a whole month or in a whole year. That helps the company, the telecom company, to decide how many or how much resources are being used by the customer. The program related to this is 11.2 Poisson. You can find all these programs in my GitHub repository. They are all updated in my GitHub repository. Once we run the program, we get all these values, current function value, and about our uploaded data. Here we have taken three random datas, y, x1 and x2. So dependent variable is y. All these values here are about our Poisson regression. So this is our module 11th. Our next module is about association rules. Thank you. Hello everyone, the last module of our assignment is association rules. Association rules consist of This module consists of three questions: how to mine association rules using Python, how to apply confidence difference, and how to apply the confidence quotient criteria using Python. First of them is how to mine association rules. So association rules is basically a data mining technique that tells us about the different relationship between entities. Like, it is very much used in transactional databases such as grocery stores and malls, where a person buys, if a person buys some commodity, how much likely he is to buy some other commodity related to it, such as milk, eggs, and honey, things like that. So in order to do this, we have the program how to mine association rules. We will import the pandas library and the ml extend. If we run this program, we get all these entities and how often they are bought together. There are a total of 12 rows and 10 columns. So this is our data where the five transactions are given: how often milk and onion are bought together, how often milk and apples are bought together, all sort of information like that. Our next topic is how to apply the confidence difference criteria. The confidence difference is basically difference in the confidence values of two scenarios, like where milk and butter was bought together and milk and bread was bought together. So as the definition states, it would generally refer to a rule or condition applied to the difference in confidence values between two scenarios or rules. In the context of association rule mining, it might be used to evaluate or filter rules based on the magnitude of difference in confidence level. So the confidence levels are basically how much likely milk and bread are to be bought together. So we have a program for this as well, which was 12.2 confidence. If we run this, we get the difference is statistically significant, means that the milk and bread are to be bought together, are much likely to be bought together. Our next is how to apply the confidence quotient criteria. The confidence quotient is basically Confidence, comparing the confidence values of two different scenarios. As it is written, one way to do this is by calculating the difference in confidence between two rules and is setting a threshold to determine if the difference is significant or not. By apply this criteria, you can identify rules with a substantial difference in confidence and prioritize them in your analysis. We have program for this as well. You can find all these programs in my GitHub repository, which is pinned down in my website. I will mention the website here. If you run this, you get all this data of the commodities that are bought together, how likely they are bought together. So this is our module 12, how to apply the confidence quotient criteria using Python. Thank you everyone.